I'm Albert Einstein, and today we are simulating a modern podcast where ideas travel across centuries. I'll be talking with Isaac Newton, one of the minds who laid the foundations of how we understand the universe. This isn't a class or a typical debate. It's a clash of perspectives on time, space, and reality. If you enjoy this kind of content, hit like, subscribe to the channel, and comment which historical genius you want to see next on the podcast.
Before we begin, I need to establish something I consider fundamental. This encounter is not a spectacle or a competition to determine who possesses the most brilliant truth. It's an experiment of another kind, observing how two minds operate when they confront not the universe, but each other. I've dedicated my life to structuring what was once chaos motion light, gravity, and I know that all genuine knowledge demands a rigorous method, a solid starting point. Without that foundation, any conversation devolves into empty rhetoric. Therefore, I propose we evaluate our ideas not by their elegance or audacity, but by their capacity to withstand direct scrutiny. Let what we say here be verifiable, questionable, dismantled if necessary. I'm not seeking applause or easy consensus. I'm seeking precision. And if by the end of this dialogue neither of us has modified our position, at least we'll have clearly delimited exactly where our disagreement lies. That in itself would already be a valuable result. Knowledge advances when we know what questions to ask ourselves, not when we believe we have all the answers. Let's begin, then from there.
I accept your proposal, Isaac, though I must confess I've always distrusted starting points that are too solid. Not because I despise rigor, quite the contrary, but because I've learned that initial certainties can become invisible prisons. For years I was treated as a symbol of something I didn't even control: genius, revolution, the break with the past. But the truth is more humble and more interesting. My ideas didn't emerge to destroy yours, they emerged because your framework stopped working in extreme situations. That doesn't make it false, just incomplete. And that distinction matters. I agree we need rigor, but we also need something more difficult: the willingness to distrust our own intuitions. The universe has no obligation to conform to what seems reasonable to us. That's why I propose this dialogue also be an exercise in intellectual humility. Let's set our ideas in motion, confront them with boundary cases, see where they break. Because theories, like people, show their true nature under pressure. I'm here not to win, but to think out loud with you.
The intellectual humility you're proposing sounds admirable, but I suspect it conceals a trap. You speak of boundary cases, as if the exceptional had more value than the ordinary. But true knowledge must first explain the common, the constant, what repeats itself every day before our eyes. An apple falls, the planets orbit, the tides rise and fall. These phenomena aren't trivial, they're the very structure of reality. If your theory only works in extreme condition speeds close to light, monstrous gravitational fields, then it's not replacing it's occupying a different territory. What I built remains valid for 99% of human experience. And that validity is not minor, it's the foundation of everything else. I'm concerned that your emphasis on the extreme takes us away from the fundamental. The universe is not defined by its oddities, but by its regularities. And those regularities demand a precise, mathematical language that leaves no room for ambiguities. Distrusting intuitions is fine, but what do you put in their place? If everything is relative, from where do you judge?
I'm not saying everything is relative in the sense of arbitrary. I'm saying that all measurement, all observation, all certainty depends on the point of view from which it's performed. And that dependence is not a defect, it's a profound revelation about how the universe works. You are right, your laws explain the falling apple, the orbit of planets, daily life. But precisely because they work so well under those conditions, we assume they describe reality as it is. And there's the error. They describe reality as it manifests at low speeds and weak fields. When conditions change, the manifestation changes. I'm not destroying your edifice, I'm showing it was built on specific ground. What I propose is not abandoning precision, but expanding the framework. Because what we call exceptional, light, time, space, turns out to be more fundamental than the tides. The ordinary is just a particular case of something vaster. And if we want to understand the entire universe, we can't stay in the garden where apples fall vertically. We must ask ourselves, what does falling mean when space itself curves?
That question is fascinating, but also dangerous, because it implies that before answering it we must question what space is, what time is, what causality is. And if we start there, we never advance. The scientific method demands starting from the observable and building upward, not from abstract speculations downward. I didn't assume my laws describe reality, as it is I assumed they described the constant relationships between phenomena. Mass force acceleration. Those relationships are verifiable, predictable, useful. They work. And working is not trivial. It's everything. When you say space curves, you're using a geometric metaphor to explain something you haven't yet demonstrated is necessary. Why complicate what's already solved? Occam's razor warns us against multiplying entities unnecessarily. If I can explain planetary motion with forces and Euclidean geometry, what do I gain by introducing a distorted geometry of space itself? I gain rhetorical elegance, perhaps. But do I gain truth? Or do I simply replace a clear explanation with a more obscure one?
I'm not seeking to complicate for aesthetic pleasure, Isaac. I'm seeking descriptive honesty. Your question is legitimate. Why abandon an explanation that works? The answer is simple, because it stopped working completely when we measure with sufficient precision. Mercury's orbit doesn't obey your equations. Light deflects near the sun in ways your theory doesn't predict. These aren't calculation errors, they're real phenomena your framework can't absorb without arbitrary patches. And there's the difference between useless complication and necessary complexity. If I introduce the curvature of spacetime, it's not for elegance. It's because that idea unifies in a single principle what previously required separate explanations: gravity, inertia, geometry. Occam's razor doesn't demand superficial simplicity, it demands deep explanatory economy. A single principle that encompasses more phenomena is simpler than multiple disconnected patches. What seems obscure to you is just unfamiliar. But the unfamiliar, when it becomes familiar, reveals structures clearer than the previous ones. I'm not replacing your clarity with obscurity. I'm showing that your clarity was local.
That defense would be convincing if you weren't changing the criterion for success mid-argument. First you say my theory fails because Mercury deviates, but that deviation is minuscule seconds per century. Then you say your theory is better because it unifies concepts that were previously separate. But unification is not the same as truth. I can arbitrarily unify anything if I'm willing to introduce enough abstractions. What matters is not conceptual elegance, but the capacity for exact and repeatable prediction. And on that terrain, my laws have functioned for centuries without need for revision. Engineers build bridges with them. Astronomers calculate eclipses. Navigators cross oceans. All of that works because the theory is robust, not because it's perfect. Do you expect every theory to be eternal? None is. But as long as it works in its domain, it deserves respect, not premature demolition. Your insistence that my clarity is local sounds like condescension disguised as generosity, as if I had done well for my time.
There's no condescension, Isaac. There's recognition that every theory has a domain of validity, including mine. Someday someone will find the limits of relativity, just as I found yours. And that won't make my work less valuable, it will make it more honest. Science doesn't advance through accumulation of eternal truths, but through progressive refinement of useful approximations. What bothers me is not that you defend your theory, you have every right, but that you treat practical functioning as proof of ultimate truth. Bridges hold, yes. But Ptolemaic predictions of the stars also held for centuries, with increasingly complex epicycles. They worked. Until they stopped working well. And then someone proposed something simpler, that Earth isn't at the center. Was that premature demolition? No. It was belated honesty. The difference between you and me is not that I seek to destroy yours. It's that I accept mine will also be, eventually, insufficient. And that doesn't terrify me. It liberates me. Because it means the universe is more interesting than any individual mind can capture.
Accepting in advance that your theory will be insufficient is not humility, Albert. It's intellectual cowardice disguised as wisdom. If you build knowing it will collapse, then you never build with the seriousness that true knowledge demands. I didn't seek eternal truths out of vanity. I sought them because only solid structures allow progress. Each generation must be able to rely on the previous one without fearing the ground will give way. And yes, perhaps my laws have limits, but those limits don't invalidate their core. The question you should ask yourself is not does it always work, but does it work well enough to be the foundation of something greater? Because if the answer is yes, then you're not replacing it, you're extending it. And if the answer is no, then you're not doing science. You're doing speculative philosophy. You speak of liberation, but I see dispersion. You speak of honesty, but I see lack of commitment. True intellectual courage is not in accepting you'll fail. It's in trying not to fail, and in that attempt, building something that transcends your own existence. That's what I did. Did you?
What I did was exactly that. Build on what you left, not destroy it. But building on something doesn't mean preserving it intact. It means understanding which parts bore the weight and which were temporary scaffolding. Your equations remain valid in their domain because they correctly describe how objects behave under certain conditions. But the conceptual framework, absolute space, absolute time, action at a distance, that framework did have to change. Not on a whim, but because experiments demanded it. Light doesn't obey your rules for adding velocities. Time doesn't pass equally for observers in motion. These aren't details, they're fundamental fractures. And yes, accepting my theory also has limits is not cowardice. It's the only stance coherent with the nature of scientific knowledge. Because science is not a finished building, it's a process of permanent correction. What you call commitment, I call rigidity. And rigidity, Isaac, prevents seeing what doesn't yet fit. What's your answer when the universe doesn't cooperate with your certainties?
My answer when the universe doesn't cooperate is simple: measure better. Because most of the time, what seems like a contradiction is an observation error or an unconsidered factor. For centuries, astronomers believed they saw irregularities in planetary movements that later turned out to be explainable with more precision in calculations. They didn't need to change the laws, they needed to apply them correctly. That's the difference between rigor and impatience. You see a deviation in Mercury and conclude space curves. I see that deviation and ask myself, have we considered all the forces at play? Is there an undetected planet? Are there second-order effects we're ignoring? Exhausting explanations within the existing framework is not rigidity, it's responsibility. Because if every anomaly justifies a conceptual revolution, then we never accumulate stable knowledge. We only replace one belief system with another. And that's not science. It's intellectual fashion. The fractures you mention, light, time, simultaneity, are fascinating, no doubt. But before redefining space itself, are you sure you've completely understood how light works within the classical framework?
Yes, Isaac. I'm sure. Because before proposing relativity, I studied Maxwell's electromagnetism thoroughly. And there's the problem: his equations, which perfectly describe light, are not compatible with your velocity transformations. If light is an electromagnetic wave, and it is, then it should have an absolute velocity with respect to some medium, like sound in air. But all experiments show that the speed of light is constant for any observer, regardless of how they move. That's not a measurement error. It's an obstinate fact. And that fact destroys the idea of absolute time. Because if two observers in relative motion measure the same speed of light, then their clocks can't be synchronized in an absolute way. Time must be relative to the state of motion. I didn't invent that conclusion for aesthetic taste, I derived it logically from experiments that couldn't be explained any other way. And when I accepted that derivation, everything else followed: space contraction, time dilation, mass-energy equivalence. It wasn't an arbitrary revolution. It was the only coherent exit facing data incompatible with your framework.
That the speed of light is constant for any observer is, I admit, a disconcerting result. But disconcerting doesn't mean inexplicable within a revised framework that preserves the fundamental. Perhaps absolute time and space need technical adjustments, but that doesn't force us to renounce the very notion of a privileged reference frame. There could exist a state of absolute rest with respect to which all measurements are corrected, even if it's experimentally inaccessible. What disturbs me about your solution is not just that it abandons intuition every deep theory, does that, but that it makes mysterious what was previously transparent. Under my laws, causality is clear. A force acts, an object responds. Cause and effect are separated by time, which flows uniformly. But in your framework, the temporal order of two events can be reversed depending on who observes them. That's not just counterintuitive, it's philosophically problematic. How can there be natural laws if the very order of events depends on the observer? You say your conclusions are logically necessary, but logic is not synonymous with reality. I need you to explain not just what your theory predicts, but what it means ontologically.
It means the universe has no obligation to conform to our intuitions about causality, Isaac. But don't worry, relativity doesn't destroy causality, it refines it. No observer can see an effect occur before its cause if they're causally connected, that is, if light has time to travel between them. The only thing that gets reversed is the order of events spatially separated in such a way that no light signal can connect them. Those events are causally independent, so their order is physically irrelevant. Causality is preserved because it's limited by the speed of light. And that limitation is crucial, it prevents paradoxes. What changes is not physical reality, but our understanding of which aspects of experience are absolute and which are relative. The distance between two events is relative. The time between them is relative. But something remains absolute, the spacetime interval, which combines both in an invariant way. That interval is the same for all observers. So I haven't eliminated the absolute, I've discovered where it really resides. Not in space or time separately, but in their indissoluble union. Is that counterintuitive? Yes. Is it true? The experiments say yes.
Experiments say your numerical predictions match measurements. That's not the same as saying your interpretation of spacetime as a unified entity is true. There could be multiple interpretations mathematically equivalent, but conceptually distinct. Choosing one over others requires criteria that go beyond pure empiricism, and that's where your argument becomes vulnerable. You say the spacetime interval is absolute, but that interval is a mathematical construction, not a physical object. I can't touch it, measure it directly, or observe it. It's a useful abstraction, very useful, I acknowledge, but it remains an abstraction. While the time my clocks mark, the space my objects traverse, those are direct magnitudes. Betting ontology on mathematical abstractions is risky. What if mathematics doesn't reflect the structure of reality, but only our limitations in measuring it? What if unified spacetime is just a convenient artifice, but not the thing itself? I'm not rejecting your theory. I'm demanding you separate what works from what you claim exists.
That demand is reasonable, but also impossible to satisfy completely. Because every physical theory, including yours, operates with abstractions that are never the thing itself. Mass, force, acceleration, none of these is a pure physical object. They're concepts we invent to organize our observations. When you say gravitational force acts instantaneously at a distance, what is that force? Where does it reside between Earth and Moon? You can't touch it or measure it directly. You can only infer it from its effects. The same occurs with spacetime. I don't see it directly, but I see how objects move within it, how light deflects, how clocks desynchronize. And all those observations are coherent with the idea that spacetime is a real structure that can curve. I could be wrong about the ontology, yes. But then you were too regarding your concepts. The difference is I'm explicit about the limitations. I don't claim direct access to ultimate reality. I claim to build models that work better than the previous ones. And that, Isaac, is all science can honestly do.
If everything is provisional models and no theory accesses ultimate reality, then we're playing a game without an end. And that game, however fascinating, loses its purpose. Because if tomorrow someone proposes another model that works even better, in what sense can we say we're approaching truth? Perhaps we're only accumulating increasingly sophisticated fictions. That stance, which you call intellectual honesty, I call epistemic resignation. I preferred to believe in yes, it's a belief that the laws of nature reflect something real, not just useful patterns, because that belief allowed me to work with conviction. If I had thought everything was provisional, I would have lost the impulse necessary to face decades of tedious calculations. Emotional commitment to truth is not a weakness, it's the engine of discovery. Your conceptual flexibility is admirable, but it can also be paralyzing. If every concept is negotiable, how do you choose which direction to advance? How do you decide what's worth investigating? Or do you simply follow anomalies without a map, hoping something interesting emerges?
I don't follow anomalies without a map, Isaac. I follow principles of symmetry, simplicity, and internal coherence. Those principles aren't arbitrary, they're informed bets about how nature works. For example, I bet that physical laws must be the same for all observers, regardless of their state of motion. That bet didn't come from nowhere, it came from observing that electromagnetism already had that property, but classical mechanics didn't. So I asked, what must I change in mechanics so it also has it? And the answer was, absolute time. That's not dispersion, it's coherence pursued with discipline. As for emotional commitment, I understand it. I also needed to believe I was close to something true to keep going. But I learned to hold that belief without making it dogma. Because the universe owes nothing to my emotions. If it shows me I'm wrong, I must accept it. Not out of resignation, but out of respect for what I study. Is that paralyzing? Only if you confuse certainty with motivation. I find motivation precisely in uncertainty. Because if I already knew everything, what would be left to discover?
You find motivation in uncertainty because you've lived in an era where science was already institutionalized, where knowledge flows collectively and each discovery is published and discussed almost immediately. But I worked in a different world. I had to build the adequate mathematical language from scratch. I had to invent calculus because it didn't exist. And I did it without knowing if anyone else would understand or if my ideas would survive my death. That solitude forces commitment to something solid, something that sustains not just the intellect, but also the spirit. It's not dogma, it's existential necessity. You speak of symmetry and coherence as guides, and that's fine. But those guides only work when you already have a solid framework from which to operate. I had to build that framework. And to build it, I needed to believe what I was erecting was more than a temporary approximation. I needed to believe it was truth. Perhaps your flexibility is a luxury you could only afford because I before you was rigid. Have you considered that?
Yes, I've considered it. And you are right, I stood on your shoulders. But that doesn't invalidate my point. Because what allowed me to see further wasn't just your rigidity, but also your willingness to break with the past when necessary. You didn't accept Aristotelian explanations of motion. You didn't settle for saying objects fall because they seek their natural place. You demanded quantitative laws, verifiable ones, that worked without exceptions. That was, in its time, a revolution as radical as mine. So don't tell me rigidity is always a virtue. The virtue was in knowing when to be rigid and when to be flexible. You were rigid with method, but flexible with old ideas. I'm rigid with principles of symmetry, but flexible with inherited concepts. We are not so different in that. The difference lies in what we consider negotiable. And there, indeed, we disagree. But disagreeing doesn't mean one is wrong. It means we are exploring different territories of the same universe. And both territories matter.
Very well, let's say both territories matter. But then you must face an uncomfortable question. If your ideas only become relevant in extreme conditions, extremely high speeds, monstrous gravitational fields, what practical utility do they have for ordinary life? Because all my work was born from concrete problems, predicting eclipses, calculating orbits, designing optical instruments. It worked because it connected directly with experience. In contrast, your most dramatic predictions require experiments we can barely perform. Time dilation is imperceptible at human speeds. Space curvature is only detected near massive stars. So for whom are you building this theory? For future physicists who may never exist? For a hypothetical universe no one will inhabit? I'm not questioning the mathematical validity of your equations. I'm questioning their relevance. Because if knowledge doesn't transform how we live, if it doesn't give us power over our environment, then it becomes an intellectual luxury. Beautiful perhaps, but sterile. Defend your theory from utility, Albert, not from elegance.
Utility isn't measured only in immediate applications, Isaac. It's also measured in deep understanding. Understanding that time is not absolute transforms our vision of the universe, even if we don't build a machine that exploits that idea tomorrow. And besides, you are wrong to assume relativity is only theoretical. It already has concrete applications. Atomic clocks in orbit must be corrected for relativistic effects, or the global positioning system would collapse. Particle accelerators work because we calculate trajectories using relativity. With your equations, they'd fail completely. Nuclear energy, both in reactors and weapons, is a direct consequence of mass-energy equivalence. So no, I'm not building for a hypothetical future. I'm building for a present that already depends on these ideas. But even if there were no applications, knowledge's deepest utility is understanding how reality works. Because that understanding, sooner or later, generates unthought-of technologies. Your equations of motion seemed abstract in their time. Today they're the basis of modern engineering. Why couldn't mine be tomorrow's?
The examples you give are impressive, I acknowledge, but something more fundamental troubles me. You say understanding how reality works is the deepest utility. But what does understanding mean in your framework? Because if space and time are relative to the observer, then each person is, literally, inhabiting a slightly different reality. Their clocks mark differently. Their rulers measure differently. Their laws don't coincide. How can there be shared knowledge if the very structure of experience varies between observers? I built on the idea that an objective world exists, independent of who observes it. That objectivity is what makes science possible. If you dissolve it into multiple perspectives, then each observer has their own partial truth. And if all truths are partial, how do you decide between them? Which is the correct measure of time? The observer at rest or the observer in motion? You'll say both are equally valid, but that answer doesn't solve anything. It only postpones the problem. Science needs a shared criterion of truth. Without that, we have perspectivism, not knowledge.
You are right that measurements differ between observers. But don't confuse relativity of measurements with relativity of laws. The laws of physics are absolute. What changes is how they manifest according to the state of motion. All observers, regardless of their velocity, will obtain the same equations of physics. That's the deep objectivity. We don't need everyone to measure the same thing to have shared knowledge. We need everyone to be able to translate others' measurements using coherent transformations. And that's exactly what relativity provides. The shared criterion of truth isn't that everyone sees the same thing, but that everyone can correctly predict what others will see. That's more robust than your objectivity, because it doesn't depend on a privileged frame. There's no correct observer from which to measure true time. There are infinite observers, all equally valid, whose measurements relate through precise laws. That network of coherent perspectives is more objective than a single viewpoint declared absolute. Because in your framework, who decides which is the absolute rest frame? You?
Not me. The universe itself. There must exist a privileged reference frame, even if it's experimentally inaccessible. Otherwise, we fall into a relativism that destroys the very possibility of objective truth. And yes, I know that sounds dogmatic, but certain dogmas are necessary for science to function. One of those dogmas is the existence of a world independent of the observer. Another is strict causality. If a cause is B, then it always precedes B for all observers. Your theory questions both, and while I admit you've built a coherent system where those dogmas are relaxed, you haven't demonstrated that relaxation is necessary. Perhaps it's only possible. And between possible and necessary there's an epistemological abyss. Because if multiple theories are possible, how do we choose? You say yours predicts certain phenomena better, and I believe you. But better prediction doesn't imply better ontology. There could be an even better theory tomorrow. So what then? Do we change ontology every time measurements improve? That's not cumulative knowledge. It's perpetual substitution. And perpetual substitution leaves us without anchors.
Anchors aren't in immutable concepts, Isaac. They're in the scientific method itself: observe, theorize, predict, verify, correct. That cycle doesn't change, even if concepts evolve. And yes, it's uncomfortable to accept our current best theory will be replaced. But that discomfort is preferable to the illusion of definitive certainty. Because definitive certainty blinds us to new evidence. Look what happened with phlogiston, with luminiferous ether, with spontaneous generation. All were theories that seemed solid, backed by decades of experimentation. Until they stopped being so. I'm not saying every theory is equally provisional. Some are more robust than others. Yours were for centuries. Mine have been for a century. And perhaps they'll last another, or perhaps not. But that, perhaps, doesn't leave us without anchors. It frees us to continue exploring without fear of discovering we were wrong. Because being wrong, when done with rigor, is the first step to being less wrong. And that's the only form of genuine progress I know.
Then you admit your theory will also be replaced, which means you haven't solved the problem, you've only displaced it temporally. In 100 or 200 years, someone will say of you what you say of me. Einstein worked well in his domain, but now we know he was wrong in the fundamentals, and that someone will be right, according to your own logic. Don't you see the trap? If all knowledge is provisional, then nothing is really knowledge. They're just hypotheses awaiting refutation. And living intellectually in that perpetual uncertainty is for me unsustainable. I need to believe that when I demonstrate something with mathematical rigor and experimental verification, I've captured a truth that will endure. Not necessarily complete, but solid. Your ideas may be correct as extension, but wrong as replacement. Because replacing implies declaring the previous false. And my laws aren't false. They're exact in their domain. If you concede that, then we're not in fundamental disagreement. But if you insist my conceptual framework is surpassed, then you're committing the same error you criticize, confusing extension with refutation.
I don't confuse extension with refutation. I confuse approximation with fundamental truth. Your laws are exact in your domain because that domain is a limiting case of something more general. Just as Euclidean geometry is exact on flat surfaces, but ceases to be on curved surfaces. No one says Euclid was wrong, they say his geometry is local, not universal. Same with your laws. They work magnificently when velocities are low and fields weak. But that validity doesn't convert your concepts, absolute space, absolute time, into ontological truths. They're approximations that work under certain conditions. And that's not trivial. In fact, it's enormous. But it's not the same as being fundamental. The difference matters because it affects how we think about the universe. If we believe space and time are absolute, we seek explanations that preserve that structure. If we accept they're relative, we seek explanations that exploit that flexibility. And it turns out the second search has been more fruitful. Not by moral superiority, but by greater correspondence with observed phenomena. Does that make me possessor of definitive truth? No. But it brings me closer than you.
Brings me closer than you. There it is. Finally you admit it. You're not seeking dialogue, you're seeking victory. All your discourse about intellectual humility was rhetoric. Because in the end, what you really believe is that your theory is superior to mine. And perhaps it is in certain aspects. But that superiority is technical, not philosophical. You predict certain extreme phenomena better, yes. But that doesn't give you the right to declare my conceptual framework obsolete. Because that framework remains the way humans experience the world. Time flows. Space extends. Objects move. Those intuitions aren't errors, they're the basis of our cognition. And if your theory contradicts them, then your theory is moving away from human experience, not approaching it. Perhaps that's inevitable. Perhaps the deep universe is radically different from how we perceive it. But then don't talk about greater correspondence with observed phenomena. Because the phenomena you observe require sophisticated instruments that amplify imperceptible effects. I worked with directly observable phenomena, which is closer to reality, what everyone sees or what only you measure.
Reality has no obligation to be directly observable, Isaac. Bacteria existed before the microscope. Atoms existed before we could detect them. Direct observability is not a criterion for existence. And human intuitions, however useful, are not reliable guides to the deep universe. For millennia, humans intuited the Earth was flat and the sun revolved around it. Those intuitions were coherent with daily experience. But they were false. Does that mean we should despise experience? No. It means we must interrogate it critically. And when instruments show us that time dilates and space contracts, we can't take refuge in, but that doesn't feel that way. Because the senses evolved to survive on the African savanna, not to understand black holes or speeds near light. My theory doesn't move away from human experience, it moves away from human sensory prejudices. And that distance is not a defect. It's a virtue. Because the universe wasn't designed to be intuitive. It was designed, if it was designed, to be coherent. And that coherence, sometimes, demands abandoning the familiar.
Abandoning the familiar. What a revealing phrase. Because it implies the familiar is an obstacle, not a starting point. But all science begins with the familiar. Water boils, stones fall, planets move. From those simple facts, we build general laws. If we begin by despising everyday experience as sensory prejudice, then we lose contact with what makes science matter, its capacity to explain the world we live in. Not the hypothetical world of black holes or light speeds, but this world here now. The world where engineers design bridges, doctors calculate projectile trajectories, farmers predict seasons. That world doesn't need your relativity. It works perfectly with my laws. So, the question is, for whom are you doing science? For an elite of physicists who can afford to think in abstractions, or for humanity that needs concrete tools to solve concrete problems? Because if it's the first, then admit your theory is an intellectual luxury. Valuable, yes, but not indispensable.
It's not a luxury, Isaac. It's a necessity you don't yet fully recognize. Because while it's true most everyday applications work with your laws, that doesn't mean understanding the deep universe is irrelevant. All advanced technology, from nuclear energy to communication satellites, depends on principles your laws can't explain. And those technologies aren't luxuries, they're essential infrastructure of the modern world. Besides, you are creating a false dichotomy between the familiar and the deep. I don't despise everyday experience, I respect it so much I want to understand why it works as it does. And it turns out it works that way because we live in a regime where velocities are low and fields are weak. But that regime is a particular case, not the universal norm. If we want to understand the complete universe, from the Big Bang to black holes, we need laws that work in all regimes. And those laws, inevitably, will be less intuitive. Not because I seek complication, but because the universe is, in fact, more complex than it appears at first glance. Is that elitist? Only if you believe truth must be accessible without effort.
Truth must be accessible without impossible instruments. Because if to verify your theory, we need atomic clocks orbiting Earth, then we're building on sand. What if those instruments have systematic errors we haven't yet detected? What if the corrections you attribute to relativistic effects are in reality artifacts of the instruments themselves? I'm not saying they are. I'm saying dependence on ultra-precise technology introduces an epistemic fragility my laws don't have. Because I can verify free fall with an apple and a stopwatch. I can verify planetary orbits with a telescope and patience. That direct verifiability is what makes knowledge robust. In contrast, your theory is verified with experiments requiring billions in infrastructure and decades of preparation. And if those experiments fail, how do you know if the theory failed or the experiment? Simplicity of verification is not just a convenience, it's a guarantee of reliability. The more complex the experiment, the greater the probability of error. And you're betting your theory on extremely complex experiments. Doesn't that trouble you?
It would trouble me if the experiments were isolated. But relativity has been verified by multiple independent experiments, using different methods in different contexts. Time dilation has been measured with cosmic muons, with atomic clocks on planes, with GPS satellites. Space curvature has been observed in light deflection during eclipses, in gravitational lensing, in the orbits of stars near black holes. It's not a single complex experiment, it's hundreds of experiments converging on the same conclusions. That convergence is the guarantee of reliability. And yes, modern instruments are sophisticated. But so are the calculations that allow designing those instruments. Complexity is not the enemy of truth, it's a sign we are exploring more subtle territories. As for epistemic fragility, I remind you your own laws depended on astronomical measurements that, in their time, were extremely difficult and prone to errors. The difference is we now have better instruments. But the principle is the same, observe with the greatest possible precision and build theories coherent with those observations. Or didn't you trust your telescopes?
I trusted my telescopes because I could verify their results with other instruments and with independent theoretical predictions. But I recognize your point. All measurement depends on instruments, and all theory depends on measurements. There's no escape from that circularity. What troubles me is not the circularity itself, but the speed with which we declare something verified. Because verification is not just confirming numerical predictions, it's understanding why those predictions work. And there, I must admit, your theory has something mine doesn't, an almost perfect internal coherence. Maxwell's laws, which I never fully integrated into my system, fit naturally into yours. That integration is admirable, but I worry that internal coherence gets confused with external correspondence. It's possible to build beautiful logical systems that don't describe reality. Mathematicians do it all the time. So my question is not whether your theory is coherent at is, but whether that coherence guarantees you're describing the real universe or just a possible universe. And that distinction, Albert, you've never addressed satisfactorily.
You are right. I haven't addressed it satisfactorily because it can't be addressed satisfactorily. There's no definitive criterion that separates possible universes from real universe beyond correspondence with experiments. And that correspondence is always provisional. Perhaps we are describing only a possible universe that, by chance, closely resembles ours in the aspects we've been able to measure. That's uncomfortable, I admit. But it's honest. Because the alternative is to pretend we have direct access to reality's ultimate structure, and that's an illusion. All we can do is build models that work increasingly better and trust that, in doing so, we approach asymptotically something resembling truth. But we'll never arrive completely. And that incompleteness is not a flaw in the scientific method, it's a feature of the human condition. We are finite beings trying to understand a potentially infinite universe. The best we can do is be rigorous, honest, and willing to revise our ideas when they fail. You did it with alchemy and theology. I did it with ether and classical determinism. Perhaps future scientists will do it with relativity.
And if they do, what remains of us? Not our equations, which will survive in textbooks, but our understanding. Will we have understood something real, or only played with symbols that coincidentally predicted phenomena? Because if the latter is true, then all this effort, decades of work, lives consumed in calculations, lacks deep meaning. And I need it to have meaning. I need to believe that when I deduced the laws of planetary motion, I wasn't inventing a mathematical game, but discovering how God designed the cosmos. Call it arrogance or naivety, but that belief sustained me. And I suspect that, despite all your conceptual flexibility, you also needed to believe in something similar. Otherwise, why pursue a unified field theory for 30 years? Why that obsession with finding a single principle that explains everything? That obsession only makes sense if you believe that principle really exists, not as a logical possibility, but as an ontological truth. So don't come to me with epistemic humility when you yourself bet everything on an ultimate certainty.
You are right. I bet on that certainty because I needed a north. But I also learned, too late, perhaps, that obsession can become a trap. I spent 3 decades seeking a unified theory and failed. I failed because I was so convinced it must exist, that I ignored science. Perhaps the universe doesn't work that way. Perhaps there's no single elegant principle that unifies everything. Perhaps nature is, fundamentally, plural. And if so, then my obsession was a form of rigidity, just like yours with absolute space. The difference is I could recognize it before I died. You never could. And that, Isaac, is what separates a scientist from a dogmatist, the capacity to admit, even privately, you might be chasing a ghost. I'm not saying I was. But I can't assure I wasn't either. And that uncertainty is the price of thinking honestly. I prefer living with that discomfort than taking refuge in false certainties. Though, I admit, it's a high price. And some days, I wish I had your faith.
My faith wasn't blind, Albert. It was informed by results. It worked. And that difference is crucial. I didn't take refuge in certainties because they gave me emotional comfort, but because they predicted eclipses with precision, explained tides, allowed navigating oceans. That utility is not accidental. It's a sign I was touching something real. But I understand your point about obsession. Perhaps we both paid a price for our convictions. You, pursuing impossible unifications. I defending a framework that eventually showed cracks. But those cracks don't invalidate what we built. They only delimit its scope. And perhaps that delimitation is the true legacy, not having found definitive truth, but having established the limits of certain partial truths. If that's what we achieved, then we didn't fail. We simply completed one stage, and others will come after to complete the next. But for that to work, each stage must be solid. And there, I insist, rigidity has value, because without firm foundations, there's nothing to build on, only conceptual quicksand.
Firm foundations, yes, but not immutable ones. And I think that's where the balance lies, building with conviction, but holding that conviction lightly. Because if we cling too much, we become incapable of seeing when the moment to reformulate has arrived. And if we let go too soon, we never build anything lasting. The art is in knowing when to hold and when to release. You held magnificently for centuries. I perhaps let go too soon in some aspects, and too late in others. But both, in our way, pushed knowledge forward. Not because we were right about everything, but because we were right about enough to ask better questions. And those questions, not our answers, are the true legacy. Because answers get updated. But well-formulated questions endure. How does motion work? What is space? What is time? How does matter relate to energy? Those questions will remain relevant long after our theories are footnotes. And that, Isaac, should console us both.
Console me? I don't seek consolation. I seek clarity. And what's clear to me, after this conversation, is that you and I represent two irreconcilable impulses of human thought. You, the openness to revise everything. I, the need to anchor something. Neither can exist without the other. Because without my rigidity, your flexibility would be chaos. And without your flexibility, my rigidity would be dead dogma. So perhaps the question is not who's right, but when each is right. There are historical moments that demand solid construction, and there are moments that demand creative demolition. The problem is we almost never know which we're living in until it's past. And while we live, we must choose, build or demolish, hold or release. There's no abstractly correct answer, only situated answers. And that ambiguity, I acknowledge, is unbearable, because it means even our best decisions could be wrong in retrospect. But perhaps that's the condition of genuine thought, acting without guarantees, betting without certainties, and hoping that, in the end, we've pushed something forward.
Exactly. Acting without guarantees. That's the essence. And the question that remains for us, the one that should also remain for whoever's listening, is this: when you confront an established idea that works, but might be limiting your vision, how much should you demand from the alternative before considering abandoning the known? Do you expect absolute certainty, like you, Isaac? Or is coherence and superior explanatory power enough, as I suggest? Because that decision, how much evidence is sufficient, determines whether you'll be intellectually revolutionary or conservative. And both stances have risks. Changing too soon makes you a speculator. Changing too late makes you an obstacle. So, if you had to choose today, in your life, with your problems, what criterion would you use to decide when it's time to let go of a belief that's worked well until now? How much discomfort with the known justifies the leap toward the unknown?